Hi, in this video, we're going to talk about stateless DHCPv6. So as you can see here, stateless DHCPv6 also involves Slack. So what we are looking at here is method 2, Slack plus stateless DHCPv6 for things such as a DNS address. We'll talk more about this. But by default, the A flag is set to 1. That will remain the same, because the device will be creating its own IPv6 global unicast address. What does change is the O flag. We change that from off to on. The M flag remains the same. Okay, so here we have the router solicitation message coming from the client and then the router advertisement message. In this case, we have changed the O flag to 1. So the A flag still being 1. The end device will create its own global unicast address and use the default gateway address will be that of the source address of the router advertisement. But the O flag set to 1 tells this client, hey, there's other information that you need to get from a stateless DHCPv6 server. Now, what is this information? It could be anything, but it's generic. It's nothing unique to this client. It's the stateless DHCPv6 server is going to provide the same information to everybody, like that of a DNS server. So it goes through the DHCPv6 message process. This is showing all 4 messages. If rapid commit is used, then only 2 messages would be used between the client and the server. Okay, so how do we set the O flag to 1? We do that with the IPv6 ND other config flag on the interface. That will set it to 1. A no before this command, no IPv6 ND other config flag, will set it back to 0. Okay, so what happens? The router advertisement is sent out to all IPv6 devices from the link local address of the router, with a prefix and a prefix length. The A flag by default is left at 1, but the O flag has been changed to 1. The client will receive this information, sees that the prefix length, address auto config flag is set to 1, and it will also see the link local address. So the link local address will be the device's default gateway address. But because the address auto config flag is set to 1, the device will create its own global unicast address using the prefix in the router advertisement. Will create its own interface ID using EUI64 or a random 64-bit value. Because the other config flag has now been modified to 1, this client will then ask a stateless DHCPv6 server for any information it may have for the client, which could include a DNS address. Okay, so how do we configure all this? So we can configure a router to be a DHCPv6 server. In this case, we'll configure it to be a stateless DHCPv6 server. The IPv6 unicast command, as you know, it enables the router to send out router advertisement messages. Then we will configure this router to be a stateless DHCPv6 server. I'll show you the actual commands here in a moment. This is just the syntax. So it'll be more understandable when I show you the actual commands. So we create a pool, then we can specify anything that is, in this case, generic, because we're a stateless server, like DNS server and domain name, that we want. You know, it's the same information this stateless server is going to give everybody, right? Okay, no address information, though. The client will create its own global unicast address using Slack, the prefix in the router advertisement, and create its own interface ID. Okay, then on the interface, this is where we set the other config flag to 1. And then we also will say, hey, by the way, I am a DHCPv6 server. and that pool name will be associated with the pool name up here. We'll see the commands for that in a moment. So let's say we're going to create a router that is a stateless DHCPv6 server, but it's not going to provide the DNS server information, okay, which we have, the server is over here. The A flag has been set to 1, the O flag set to 1, the M flag remains at 0. So it created its own IPv6 address using Slack, but it's going to talk to a DH, but because the O flag is set to 1, it needs to talk to a stateless DHCPv6 server to get the address of like the DNS server. Okay, and by the way, that's going to be the router doing this, being the stateless DHCPv6 server. Yeah. So just so you understand this process here, the router is sending out both the RA message. Okay. The client will see that, sees the O flag set to 1, says, oh, I need to talk to a DHCPv6 server. So the client will look for a DHCPv6 server, and the router will go, hey, I'm also that. So it will actually provide the DHCPv6 information back to the client. Okay, so let's see how to configure this. All right, so we have our IPv6 unicast routing that sends out the RA message. And in this case, we're going to change the O flag to 1. So on our interface, gig00, we've set the O flag to 1. Okay, we also want to act as a stateless DHCPv6 server. Okay, so on the interface, this is where we're enabling this interface to act as a stateless DHCPv6 server. So when the client sends out a DHCPv6 solicit message, we will respond. Okay, so the pool name, IPv6 stateless in all caps, it's always good, pool names and things that so we don't get these mixed up with commands or parameters. It's sometimes a nice idea to use all capital letters. So that's something that we came up with, was a name that we created. Okay, so here's the pool here, and we can see that we are, as a stateless DHCPv6 server, this router is going to provide a DNS address and a domain name to the client. Okay, looking at the client, we can see that, oh yeah, it has an IPv6 address and a default gateway. Both of those came from the router advertisement. Okay, it received the prefix in the router advertisement, and then Windows used just a random 64 bits for its interface ID. The default gateway is the source IPv6 address of the router. The DNS server and domain name, it received that from stateless DHCPv6, which the router is acting as a stateless DHCPv6 server. That was the information it provided as not in the router advertisement, but as a stateless DHCPv6 server. Okay, if I did show IPv6 interface on gig00, we see some cool information. Down at the bottom, some output omitted, this tells us about the router advertisement. It says hosts are using stateless autoconfig for addresses. That tells us that the A flag is set to 1. Hosts use DHCP to obtain other configuration information. This tells us the O flag is set to 1. So this is referring to the A flag equal to 1, and this is referring to the O flag equal to 1. Okay, and if I looked at it in Wireshark, we can see that. First of all, the managed address configuration flag remains at 0. Okay, that's for stateful DHCPv6. There's our other configuration flag. It has been set to 1. Okay, all right, pretty cool. Continuing to look at the rest of this message, we can see here's the prefix information. So here's our prefix right here. So it says, use this prefix because the A flag has been set to 1. By the way, this prefix, it's on link. There's our L flag, all in the router advertisement. Okay, and just kind of a little review here. We talked a little bit about something called a DUID. We'll look at this more in stateful DHCPv6, but every DHCPv6 participant has one DUID that uniquely identifies that device. For each of its interfaces, it will have an IA, identity association. And we can actually see this when you do ipconfig/all. Here is the DUID information, uniquely identifying this client. And here's the IA information that uniquely identifies this information, this interface on this client. Okay. We can see some cool stuff. So here is its IPv6 address. This is the prefix that it received from the RA message, created its own interface ID. Because Windows uses the privacy extension, it created a second address with a different interface ID. Remember, we call this sometimes public or permanent address. This won't change. Devices can use this. Another device can use this address to send packets to this device. But any packets that are any connections, let me put it this way. If a connection is established by another device to this PC, oops, I lost my, sorry about this, there we go. If another device is sending packets to this PC, it establishes the connection, let me put it that way, then it will use this address. Okay. If this PC is establishing the connection, it's the one that's creating the connection to another device, then it's going to use the temporary address because this is going to change. Okay, that way, that's a good thing because that'll change over time. That way, people can't track, hey, Rick's gone to this website and gone to this server and done this and looked at this. And no matter what network Rick is on, if this always remains the same, it's easy to track. That's pretty unique. So we want that to change for privacy reasons. Okay. All right. We can actually look at the router's DUID information. We can see here that if it was enabled for rapid commit, and here's the pool name. There's not a lot of information as far as stateless because it's not given out much. We'll look at the router acting as a stateful DHCPv6 server next.